Alrighty, so today we're going to talk about volumes of solids of a revolution. And this can kind of be a tricky concept to grasp at first, but once you see a visual aid, it can become really straightforward. I don't want to say that it's easy, but it's pretty straightforward. Okay, so a solid of revolution is formed when a flat two-dimensional shape is rotated around an axis. So let's imagine for a second that I stuck a sticky note to a pencil, and I just twirled that pencil around and around. Well, the shape it would make would be a cylinder, okay? So that is going to be our equation that we're going to go back to find these volumes of solids, is the volume of a cylinder. So if I look at it, the volume of a cylinder is pi r squared h, right? So let's imagine for a second that I have a cylinder on its side. Okay, so here's my cylinder. Now, let's imagine that the x-axis goes straight through the center of this cylinder here. Okay, so that is the x-axis. I guess I could draw the y. So the radius of this cylinder is actually going to be whatever the function is at that point. Okay, so if I have a function here that's just a horizontal line and I rotate it about the x-axis, it's going to make a solid cylinder. So the radius is f of x. Okay, now the height of the cylinder, well, that's from point A to point B, right? So A to B, well, that is taken care of by the integral. Okay, so because we're looking at area underneath the curve, okay, imagine this is my little post-it note right here. Okay, we're looking between A and B, and then we're looking at that area and rotating it around the x-axis. All right, so the volume of this cylinder here is going to be the integral from A to B. Okay, that's going to take care of the height portion. And then it's going to be pi r squared. Well, we said that our r was f of x, so it's going to be pi times f of x squared. Okay, and then don't forget the dx. Now, it all depends. So this is if you're rotating around the x-axis. If you're rotating around another axis, you have to take that into account. So the general equation for volume is v is equal to pi. We're going to kick that pi out of the integral from A to B of f of x minus whatever axis squared dx. Okay, so in our case, since we're rotating around the x-axis, well, that's y equals 0 is right there. Okay, so it would be f of x minus 0. Okay, if you're not quite understanding kind of how this looks, if you Google volumes of solids of revolution, there's a website called GeoGebra that has a really good example. You can plug in different functions and see what it looks like rotated around the x-axis. So I highly recommend that you look at that if you are still confused. Okay, so let's do a couple of examples. So this first one here, we call it the disk method. Okay, so imagine that I have my cylinder. Okay, here's the x-axis. And so imagine that I'm just going to take a tiny little slice out of that cylinder. okay? Well, if you look at it on end, it's going to just be a circle, okay? The x-axis is going to be in the middle there. Up to that point, that's going to be f of x, all right? And so this is just a tiny little portion, and so it's a solid circle. That's why we call it a disk, okay? So it says find the volume of the solid formed by rotating y around the x-axis. Now this is not in your notes, so I would do this on a separate sheet of paper or maybe on the back of your notes. So remember, we're going to use the equation v is equal to pi r squared h, okay? So we have pi, now our integral. In this example, we're going to be looking between 0 and 2. Okay, so that's where our integral is going to go. And then it is f of x minus the axis, which is just 0, squared. Okay, so v is going to equal pi from 0 to 2. Well, f of x is just x squared dx. Okay, so from 0 to 2, x to the 4th dx. Okay, now if you punch that into your calculator, you should get 32 pi over 5. Okay, you can multiply the pi in there, that's totally fine. It's up to you. Okay, I usually don't, I leave it out. But that is the total volume if you rotate this graph around the x-axis, okay, and look at the volume from 0 to 2. Alright, so let's look at another example here. Now we're not rotating around the x-axis, now we're going to rotate around the line y equals -2. Alright, so in keeping with the equation, it goes from a to b of f of x minus your axis squared dx. Okay, so in this case, the volume is going to be pi. We're going to look from 0 to 2 again. Sorry, I don't have that actually labeled there. And we're going to look at f of x minus, well, this is the axis that I'm rotating around, so -2 squared dx. So simplify, you get x squared plus 2 squared dx. Okay, and if you punch that into your calculator, you should get 376 pi over 15. I'm not sure what that is in a decimal form. Okay, but that's rotating around y equals -2. Now this totally makes sense because we're looking at the area under f of x, so we're looking at this area here, but we also have to take into account this area as well. Okay, that's why we add the 2 there. Okay, so just remember that it's always f of x minus the axis. Alright, let's look at one more. Okay, so we're going to find the volume of the solid formed by rotating y about the line y equals 2. Okay, so we're going to look again from 0 to 2. So the volume is going to be pi from 0 to 2 of f of x minus 2 squared. Okay, so let's think about it. If we are looking at the area underneath the curve of f of x, so we're looking at this area here, and then we're rotating it about this line y equals 2, so we actually have to subtract this area. So all we're really doing is rotating this little chunk, okay, around that line there. Okay, so this would turn out to be, so x squared minus 2 Come on. Okay. Well, that makes no sense whatsoever. So v equals pi. Okay. Punch that into your calculator. Let me see what you get. I actually do not have it written down, so let's look at it here. So from 0 to 2 of x squared minus 2 so it should give you 56 pi over 15. Okay? So I hope that makes a little bit more sense. In the notes, it goes straight into the volume of washers as well. So we can kind of look at that. So let's see here. So this is what you really need to know, is this equation right here. Commit that to memory. The volume of the solid is pi r squared. Well, r is going to be your f of x minus the axis of rotation squared, and then you have the height, which is taken care of by the integral. So this next section here is what we call the washer method, okay? It's where we have two functions, and we are finding the volume of the solid rotated about some axis, and it's the two functions. So if we look at this example here, and we look at the area of this, because that's technically what we are going to rotate around the x-axis. Well, that shape, if you look at it on end, it's going to become a washer with a hole cut out. Okay, so this right here is the area that's in red here. Okay, so the way that we calculate this is it's the same process. So it's pi, the integral from a to b of the outer function minus the axis squared minus the inner function minus the axis squared. Okay, remember whenever we were finding area between two curves, you take the top function minus the bottom function, and that'll give you the area between two curves. Okay, now you just got to take into account the axis in between each one. Now, this is super important. The outer function is defined to be the function that is farthest from the axis of rotation, not necessarily the top and bottom anymore. It's the farthest from the axis of rotation. The inner function is the one that is closest. Okay? So, let's just look at an example. So consider the region pictured to the right that is bounded by the graph of y equals x squared and y equals x plus 2. Find the volume of the solid formed when the region is rotated around the x-axis. Sorry. Okay. So remember, the volume is pi, the integral. So here we're looking at the intersection points. Okay, so we're looking at this point here and that one there. So we're looking from -1 to 2, and it's going to be the outer function minus the inner function. Well, if we're rotating around the x-axis, this function here is farthest from the x-axis. Okay, so it's going to be x plus 2 minus the axis, which is 0, all of that squared, minus the inner function, which is this one here. So minus x squared minus 0, all of that squared. Okay, so whenever you simplify this, so you get x plus 2 squared minus x to the 4th dx. Okay, and so if you punch that into your calculator, or you could do it by hand, either one is fine. you should get 72 pi over 5. Okay, so that is the volume of this shaded region rotated around the x-axis. Let's look at the next one. It says find the volume when the region is rotated about the line y equals 4. So it's always a good idea to draw that line on your graph, okay? So I have that line there. So this is where you have to pay attention to which one is the outer function and which one is the inner function. Okay, the outer function is the one that is farthest from the axis. So the outer function in this case is going to be this guy right here, which is the x squared. Okay, so to find the volume, it's pi, the integral, and again we're looking at the intersection point, so from -1 to 2, of the outer function, which is x squared, minus the axis, which is 4, all of that squared, minus, okay, the inner function, which is x plus 2, minus the axis, all of that squared. Okay, so if we simplify that a little more, what is that? X to the 4th minus 8x squared plus 16. That's what this one equals. And then minus, what is that? X squared minus 4x plus 4. I think that's what it comes out to. Okay. If you want to punch that into your calculator, you should get 21.6 pi. Okay, so that should be the volume whenever this shaded region is rotated around the line y equals 4. All right. One more. Let's find the volume when the region is rotated about the line y equals -2. So again, draw your axis. Alright, so if you think you got it, I encourage you to pause it right now and try to do it on your own, and then fast forward a little bit to see if you get the right answer. So we should have the volume, you go from -1 to 2. The outer function is going to be the top one here, so it's x plus 2 minus the axis, which is -2, so it's going to be plus 2 squared, minus the inner function, which is x squared plus 2, all of that squared, dx. Okay. If you wanted to simplify that a little more, you could. If you're good with a calculator, punch it in like that, and you should get 32.4 pi. Okay, so that's the basics of finding these volumes rotated around the x-axis. Okay, so we've talked about rotating around the x-axis and all of these horizontal lines. Now I need to talk about what happens whenever we start to rotate around the y-axis. Okay, so if the axis of rotation is the y-axis or is parallel to the y-axis, the integrand needs to be in terms of y, and the limits of integration need to be the y values of the points of intersection. Okay, so consider the region pictured to the right that is bounded by the graphs of y equals plus or minus the square root of x and y equals x minus 2. Your first step is you got to get these in terms of y. Okay, so what we're going to do is we're going to solve for x. So in this first one here, we have the plus or minus the square root of x. Well, to get rid of that, we're going to square both sides. Okay, so that means that x is equal to y squared. Okay, and over here, we're going to solve for x. So x is equal to y plus 2. Okay, now these are going to be your functions. All right, so find the volume of the find the volume when the region is rotated about the y-axis. So we're looking right here, okay, and we need to look at the y values of intersection, okay. So our integrand is going to go from, well, -1 here to 2. Okay, and then the same rules apply. It has to be the outer function minus the inner function. So it's the outer one is the farthest one away from the axis. So it's going to be this function here, which is the y plus 2. So it's going to be y plus 2 minus your axis squared minus the inner function, which is this one here, which is going to be y squared minus 0 squared. And this is going to be in terms of y. Okay, so whenever we simplify this and go from -1 to 2, I should get y squared plus 4y minus 4 minus y to the 4th dy. Okay, you punch that into your calculator and you should get 72 pi over 5. Okay, so now this one is just being rotated around the x-axis, so it makes a cylinder looking kind of like this. I know I'm a terrible drawer, but okay, it's going to look something like that. Again, if you want to look at the GeoGebra, you might be able to punch this function in and see what it looks like. Okay, let's look at the next one. So same graph. Now we are looking at the volume whenever it's rotated about the line x equals 4. So that's a vertical line. So we're looking right here. Okay, the process is the same, the outer function minus the inner function. So your outer one this time is going to be the y squared. So v is going to equal pi. You're going from the same y values, so from -1 to 2. And your outer function is going to be y squared minus the axis, which is 4, and all of that squared, minus your inner function here, which is y plus 2 minus 4, all of that squared dy. Okay, like I said, if you're good with a calculator, you can punch this in. If not, you should get something like y to the 4th minus 8y squared plus 16 minus y squared minus 4y plus 4 dy. Okay, if you're going to do this by hand, please make sure that you distribute this negative where it needs to go. Okay, if you punch it into the calculator, you should get 21.6 pi. Okay, now let's look at the next one. So find the volume when the region is rotated about the line x equals 7. Okay, so x equals 7 is not even on the graph. It's way over here. Okay, so I encourage you to pause it, and if you can figure it out, go for it. Okay, so I'm going to set it up like this. So from -1 to 2, your outer function is the y squared minus your axis squared minus your inner function minus 7 squared dy. Okay, so you should get y to the 4th minus 14y squared plus 49 minus y squared minus 10y plus 25 dy. Okay, and at this point you can punch it into your calculator you should get something like 48.6 pi. Okay? So that's the gist of finding the volume of rotation. You do have a homework. It's on page 642. And I think I'm going to go to 644. Okay? If you need help, let me know. If you watch this video and you're still super confused, always ask me questions. Okay? But good luck with the homework, and let me know if you need help.